Right, okay, morning Year 9. This video is going to go through one of the ideas from last week that I think some of you had a bit of difficulty with. Okay, so this is about resistance. So when you've got your circuit set up, we know that current flows through the wire. Now if you look on the bottom part of the diagram there, you've got an enlarged section of the wire. Now we said that metals are good at conducting electricity because they've got these delocalized electrons, which means that they can move and carry the charge through the wire. So if you look at the little orange dots there representing the atoms of the metal, so in this case it's copper, and the black dots here that are moving through the wire actually represents the electrons, and because they're moving in a flow, in a direction, that is carrying a current. Okay, so there's three things that we need to make sure that we are really comfortable with in terms of the definitions. We need to understand that current is the flow of electrons, and then we measure that in amps using an ammeter. We've also got voltage. Sometimes it's referred to as potential difference, but it's the same idea, so you need to be sort of confident with both of those descriptions. And the voltage is the energy that pushes the electrons around the circuit, so that's what comes from the battery or from the power pack or from the main supply. And then what we're going to concentrate on in this video is resistance. So resistance, if you resist something, it means that you're trying to prevent it from happening. Okay, so resistance in a circuit is something that will try and prevent the current from flowing, and we measure that in a unit called ohms, and it's got this funny little symbol here. Right, okay then, so if you look at the diagram, I know it's a bit silly, but this is representing a circuit. So you've got the little blue sort of ball people. They are representing the electrons, and they're flowing round in a circuit. Notice that they're all flowing in the same direction. Now, as they go around that assault course, some of them are going to have their speed changed. So the speed at which they flow is going to be affected. And that's really sort of trying to show you the idea of resistance. So if you look on the helter-skelter here, they're going to go much faster, so they're going to whiz down that slide, and that's going to increase their speed. As they go through the treacle pit, which is the bit across the bottom, it's going to be much more tricky for them. So that is, it's resisting their flow. The same under the cargo net sort of thing here. Okay, so anything that is slowing them down, we refer to as resistance. Now, like we've said, the more current that you've got flowing, then it's flowing faster. Okay, and we can actually change that current by increasing or decreasing the voltage of the circuit. So if we add more batteries, or if we turn up the power on the voltage on the power pack, then you will make the current flow faster, so you'll increase the size of the current. Okay, however, if you put components in a circuit, that's going to increase the resistance of the current flowing through it. Now this could be a bulb, it could be a motor, it could be a buzzer, it could be any sort of resistor itself. So any component will try and slow down because it's making those electrons do work. So it's making it harder for the electrons to actually pass through the wire. So you've got a little definition there. So resistance is a measure of how much material tries to stop electricity passing through it. Now, just in the same way that some materials are better conductors than others, then some materials have more resistance than others. So some materials are better at preventing the flow of electrons through them. Okay. Now, as the current flows through the wire, they're going to bump into the metal ions. Now, what that does is it's going to make the ions vibrate, okay, which actually increases the heat. So everything has some degree of resistance, even the best conducting wire. Okay, so that's why you need to be careful when you do practicals in school, that you don't let things get too hot and you can potentially burn yourself. Okay, so in this case, if you imagine at the moment you've got a low resistance. So if you think about shopping, for example, at the moment the shops are very, very quiet. Okay, so you can actually navigate through the aisles and around the other people's trolleys really, really easily. So that means there is a low resistance. You're not bumping into anything. Okay, so the electricity will flow really, really quickly. You can get around the supermarket quickly, okay, and the electrons can flow super, super quickly. So there's low resistance. If you go up to high resistance, if you imagine shopping at the Trafford Centre before Christmas, when everyone is out getting their Christmas shopping, there's going to be lots more people, okay? And the chances of you bumping into something else, or, you know, falling over someone's pushchair or whatever, is going to be much, much higher. So it's harder for you to navigate your way through the shops or through the supermarket, and you're more likely to bump into something else. So that is a high resistance. So like it showed, the electrons is more difficult to pass through, so there is a smaller current. Okay, now when you have resistors in circuits, there's obviously we've got two different types of circuits. We've got series circuits and we've got parallel circuits, and the total resistance provided by resistors in these circuits, we have to calculate it in two different ways. Okay, now the series circuits is really, really simple. Now I know it looks complicated because it's a diagram and it's got all these R's and numbers and it looks really tricky, but it's not. All this is showing is that in a series circuit, whatever the resistors are, you add them together, okay? So the total resistance for this series circuit is the resistance of number 1, number 2, and number 3 added together, okay? So that's all you need to do. You add the resistance together and that will give you the total resistance for the circuit, okay? So for example, in this case, you've got two resistors in the circuit. Remember, it's a series circuit because there is only one route, there's only one way that it can flow. Okay, this little symbol is resistance. So in this case, I'm just going to add 43 and 68 together, and that will give me the total resistance for that circuit, which is 111 ohms. That's what that funny little symbol stands for. Okay, another one just to practice. Again, this time you've got three resistors, they're all in a line, okay, so they're all in series. Again, all you need to do is you add them together, okay, so you've got 5 plus 10 plus another 5 would give you 20 ohms. Okay, so that's really, really straightforward. Now, you've got another example there, so 50,000, this is much bigger numbers now, 50,000 plus 500 plus 5. Okay, add them together. It doesn't change the fact that you just add them together, and that will give you a total of 50,505 ohms. Now, for parallel circuits, you have to do it in a slightly different way. And again, it looks more tricky than it is. As long as you follow it step by step, then you're not going to get in a muddle. So in this case, you still look at the numbers associated with the two different resistors. So you've got R1, which is resistor 1, and R2, which is resistor 2. Now, you have to do it in two parts. So first of all, you multiply the two values together, okay, and that will give you the top part of the calculation. And then you add the two values together, which will give you the bottom part of the equation. Okay, so we'll just work through an example. So in this case, you've got two resistors in parallel because they've got a junction. Remember, they've got branches. So the first part is that I need to multiply them together. So I've got 4 multiplied by 4. Okay, so that's the first part, that's the top half of my equation. So that'll give me 16. And then I'm going to add it together for the underneath part of the equation. So I've got 4 plus 4, which gives me 8. Okay, so I've got 16 on the top, 4 multiplied by 4, and then 4 plus 4 on the bottom. So that will give me 16 divided by the 8, and that will give me a resistance of 2 ohms. Now, something that you'll notice in this one is that the total resistance is always smaller than any of the resistors individually. Okay, so both of those are 4 ohms, but the total resistance in this case is only 2 ohms. So you've got another example. Again, you multiply them first, so I'm going to have 20 multiplied by 5 on the top, which will give me 100, and then I've got 20 plus 5 underneath, which gives me 25, so 100 divided by 25, which will give me 4 ohms. Okay, now you've got some practices on here to do, okay, so you need to pause the video, do the sums, you can check your answers because they are on the slides. And then you can go back and I will put the sheet that I gave you on ClassCharts. I'll put it back on for Monday, and then you can try and complete that again. It's exactly the same idea. In series, you add the resistance together. In parallel, you have to do that slightly more difficult equation, okay? But as long as you do it in 2 steps, multiply by together first, add together underneath, then you will get the right answer. Okay, good luck.